ocean surface winds. Does that make sense? Thanks.
Good, thank you. So our next speaker is Vu and Nguyen. Status on future plans of Spire's GNSS radio occultation and reflectometry constellation.
All right, good morning, everyone. My name is Vu, and I'll be presenting on status and future plans of Spire's GNSS constellation. Okay, Spire is a commercial company that designs, builds, and operates one of the largest multi-purpose satellite constellations in the world. One of the main focus areas of Spire's constellation has been the collection of RF signals, mainly for applications such as Earth observation, space services, and geolocation. For Earth observations, many of our satellites are equipped with a GNSS receiver, which are designed to track these signals through various geometric scenarios. Originally, the main focus was on the collection of RO signals for atmospheric profiling with, of course, benefits to NWP and climate. However, over the last several years, we've added many other capabilities to our constellation that includes the collection of reflected or GNSS-R signals that carry information about the Earth's surface, including soil moisture, sea ice, and ocean winds. Looking towards the near future, we look forward to the launching of our first hyperspectral microwave sounder. This will provide more enhanced measurements of atmospheric temperature and moisture. So the payload that we use for our GNSS measurements is called Stratus. It's a low-power GNSS receiver that can track all of the major GNSS constellations. It's housed on 3 major spacecraft configurations summarized in this table on the right. The majority of our satellites are of the GNSS-RO configuration. This is a 3-unit in cube size dimensions, meaning 10 by 10 by 30 centimeters in dimension. They're equipped with either 1 or 2 RHCP RO antennas on the limb, and also a zenith pointing POD antenna for precise orbit determination. I also like to mention that these RO antennas can also be polarimetric to collect polarimetric RO. That means that it can collect both the horizontal and vertical linear polarization components of the RO signal. We launched many of these satellites historically, operating as many as over 30 at one point. We currently operate 9 of these, and main applications here are neutral RO, space weather ionospheric, and then also grazing angle GNSS-R, which I'll cover a little bit more detail later. The second type of configuration is the near nadir GNSS-R. These have deployable antennas, 2 or 3, that point towards the Earth in the nadir direction. These are LHCP antennas operating at 1 frequency. They can be combined through beamforming to increase the SNR of the measurements. Historically, we've launched 5 of these satellites and currently operate 1. And main applications here are soil moisture and ocean wind speeds. Finally, the third type of configuration is what we just introduced into orbit. These are the first satellites that combine both RO and R on the same platform. It making for a more efficient producer of these measurements. And I'll provide more detail in the upcoming slides. So we've the Stratus receiver was first launched in 2017 and has undergone many improvements along the way. So we started with this version 1 of our receiver. This was capable of the typical rising and setting events. Along the way, we added additional GNSS constellations to the original GPS signals that we were tracking. So now we track all of the major constellations on this version. And along the way, when we were improving this receiver, we demonstrated a lot of the world's firsts for RO technology. That's including demonstrating the collection of high-quality profiles from CubeSat platform, collecting Galileo profiles, and also becoming the first provider or commercial provider of RO. Version 2 we introduced in 2022. The main benefit here is we added the capability for relative amplitude calibration, mainly benefiting the near nadir GNSS-R measurements. This receiver also has more receiver channels. This allows for more simultaneous tracking of RO events so that we can collect more profiles per satellite. On the schematic on the right, just shows the current configuration of our antenna receiver system. This hasn't changed much over the last several years. So starting from the bottom, below 170 kilometers line of sight altitude, we're collecting high rate 50 hertz RO data for the neutral atmosphere. And then as you transition upward in line of sight altitude, we're collecting 1 hertz closed loop data for the ionosphere and navigation POD. So in terms of RO production, Spire has been the world's largest producer of RO measurements over the last 5 years. We've demonstrated the capability of producing over 20,000 quality control profiles per day. For the ROMEX study in late 2022, we provided over 17,000 profiles per day, making about 50% of the total daily volume for that study. The plot on the lower left shows our daily RO production over time since 2019, monthly averaged. You can see that between 2022 and 2023, we were producing about 15,000 to 20,000 profiles per day. In late 2023, we decreased that number, mainly due to Constellation reallocation as a result of customer demand. And we've also had a slight more gradual decrease in 2024 due to satellites deorbiting and launch slips. However, in August, we did introduce 6 new satellites into orbit. This will increase our numbers back to around the 8,000 RO profiles per day level. We also introduced the first 2 of our combined RO and R capable satellites. So the schematics of those satellites are shown on the right here. You can see slight variations between the 2 satellites. One of them has 2 RO antennas and 1 GNSS panel, while the other one has 1 RO antenna and 2 GNSS antenna panels. So the trade-off being more RO measurements or more SNR on your GNSS collections. So our 2 primary operational RO data customers have been EUMETSAT and NOAA over the last several years. So on the EUMETSAT side, which has been covered by Christian, we've consistently been delivering between 1,000 and 1,600 RO per day since 2022. This transitioned to a new contract last month, and now we're delivering 1,400 RO per day. I think the main update on the EUMETSAT side is we also started the delivery of near real-time PRO data as part of these operational RO deliveries. This was after a collaboration with them where we were able to verify that the PRO measurements can be used for the derivation of traditional RO bending angle, refractivity, and temperature. So that started in May, and that's part of the RO operational deliveries at this point. On the NOAA side, we've been delivering to them since 2020, spanning 2 IDIQ contracts. We've been able to consistently meet their delivery requirements over the last several years. So the plot on the lower right here shows the number of compliant RO profiles per day that we delivered to NOAA between 2021 and 2023, showing that we consistently over-delivered by 10 to 25% over that time period. The current period has been a little bit more challenging due to reduced RO capacity. However, we've made several improvements over the past 6 months to maximize the number of profiles that we deliver to NOAA and end users. This includes the improvement of tracking our Beidou signal, and as well as reducing delivery latency to users. I'm not going to provide too much detail on our external evaluations of our data because that's been covered extensively over the past several IRWGs and other meetings. But I'd like to note that years of third-party evaluations from many of the people in this room have shown that Spire RO data to be of high quality and also meet or exceed the performance of many of the legacy operational missions. This includes when you look at the metrics of penetration depth and bending angle differences to models. Also mentioned that our RO data has been demonstrated to have a positive impact on NWP systems. That's been mentioned by other presentations before me. And I do look forward to other presentations that show this due to the ongoing ROMEX study. Now moving away from the traditional RO and to other areas. So within the past 2 years, we've launched the first of our polarimetric or PRO capable satellites. We did this in early 2023. So from these 3 satellites, we were able to demonstrate and collect over 2,000 polarimetric RO profiles per day from all 4 of the major GNSS constellations. To put that into context, that's about 10 times the amount of data currently collected from the PAWS satellite. Each of these satellites only has 1 PRO antenna. So it's from that PRO antenna, we collect the H and V components of the RO signal, and by taking the differences between those, or the phase differences between those components, we can demonstrate clear sensitivity to precipitation along the rate path, and that was done by both internal analysis and also from independent analysis from IEC. And then last thing to note, we've also demonstrated that the bending angle profiles that are derived from our PRO data have similar quality to our operational RO data that are derived from our normal RHCP antenna. On the ionospheric updates, the main update here is we participated in the NOAA Space Weather Data Pilot about 1.5 years ago, where we delivered over 500 tracks per day. For a TC, we continue to collect 1 Hertz observations. This spans across both the RO and POD antenna, allowing to produce longer ionospheric tracks that users like. We currently track only GPS for the ionosphere, but if there were more demand for it, then we would add the other constellations to that tracking. On the scintillation side, we have an onboard estimate of S4 that's used to trigger additional high rate data when we detect a high scintillation event. And in terms of current plans, we're looking forward to implementing a sigma phi based algorithm to trigger more accurate downloads, and as well as additional flagging for users that would help users separate RFI from real ionospheric scintillation events. And now just to summarize the GNSS-R updates, the 2 main types of GNSS-R measurements that we collect are grazing angle and near nadir. So the grazing angle measurements are actually collected by our GNSS-RO satellites, so we have many of them in orbit. How this works is that these are occurring at low elevation angles, and at these low elevation angles, the signal can be phase coherent over smooth surfaces such as sea ice. So this has applications for sea ice characterization and also altimetry. And then for the near nadir case, we have a handful of these satellites collecting delayed Doppler maps of the received power, and the focus there remains soil moisture and ocean winds. This was just covered by Jerry, so don't have to go in too much detail, but yeah, we participated in the NOAA Ocean Surface Winds pilot contract. We successfully delivered 500 tracks per day. This includes raw to process level 2, and also near nadir and the grazing angle measurements. In terms of technical improvements, recently, we've demonstrated how antenna beamforming allows us to retrieve wind speeds or higher wind speeds. And also we've been applying or experimenting with machine learning techniques to improve our ocean wind retrievals. All right, so to conclude, Spire currently has 10 satellites in orbit capable of collecting over 8,000 quality control profiles per day. We continually make improvements to our satellite and ground infrastructure to produce more data more efficiently. We've already demonstrated that we can produce over 20,000 profiles per day historically. If there was demand for it, we can scale that up with advance notice. So I think communication with stakeholders and NOAA and other organizations is key there. And in terms of data access, I've summarized the different avenues that research users can access our data. I think probably the main one to highlight is NASA CSDA. This contains all of our RO data, all of our GNSS-R data from 2019 to the current period, and it's available to US government-funded researchers. One thing to note that I don't think Melissa mentioned was that With the new IDIQ contract, we've transitioned to a new user interface for users to access our data. So if you wanted data beyond June 2024, you would have to go through our user interface. And actually, it should make it easier for users to access and download bulk data. So if you need more information on that, feel free to reach out to me or NASA CSDA for more information. And then also just to highlight the ESA third-party mission, that's where we've delivered a lot of our PRO and GNSS-R data. So for on the European side, if you wanted to access those data, then you can go through that avenue. So yeah, I'll end it there, and thank you.
Any questions? One question over there.
We've been using ion for data that's is there a similar set by Spire?
Yeah, so we do process TEC into TEC arcs as well as electron density profiles, and that's available through NASA. Yeah. I mean, it tries to adopt the same CDAC convention. So there's pod tech, but there's also like ion. Yeah, I can send you more information. Yeah.
Maybe Chris, we can do it in break or something, because I think, I don't know, Jan, we have a photo session also.
Yes. Are we ready? We have some instructions for the photo session, or the group photo, I should say. Yeah, so we're going to take a break until 10:35, so a little bit